So this is what the ICEM GUI of the model looks like. This is the model of a room. The tall boxes which you see here, these tall boxes, they are the models of occupants. This is a table, this is a computer, and this is the computer box, the CPU of the computer. So this is I mean, there are 8 occupants, 8 computers, and 4 tables. There are 2 inlets, the 2 inlets for air, one inlet here and here, and 2 corresponding outlets, one outlet here and here. So these are the 2 outlets and these are the 2 inlets, and there are 4 lights here on the wall, on the ceiling, 1 2 3 4. So these are the 4 lights here. So this is the model, and as you can see, this model is symmetric. It's symmetric around about this plane. This is symmetric about this plane. So to take advantage of the symmetry, we will use the copy mesh option, and we will create mesh only in one of the parts and just rotate it above the symmetry. So before we do that, we should create a plane of symmetry. I mean, we should create a surface part which coincides with the plane of symmetry. The plane of symmetry is the curves here. This curve here is defines the plane of symmetry. So for your understanding, I have already created a plane of symmetry, an artificial plane of symmetry, which is not a part of the geometry, but to take advantage of symmetry, I have already created a plane of symmetry, and I have named it as interface. So this is the interface. So as I said, we will create a mesh only in one of the parts, and we'll rotate it to take care of the other part. So let's begin our blocking. So we initialize the blocking here, and we select the part name, say fluid, because we want the block to be fluid in fluid part. And we will initialize the block only to half of the surface. So we'll switch off the surfaces which are on the other half, which is like we'll switch off the surfaces on the right side. So if you see here, I am switching off the surfaces here. Just so that I can get a better grasp. So I will now initiate the block on the left side. So I will start with the polygon option of selecting entities, and I will select here. And I press middle click and I say apply. So this is the block I have created. This is only in half of the domain, only in this half. So now we will define our study only to this half. So if you see here, we need to assign, we need to capture this triangle here. This is the inlet. This is the inlet surface, the inlet diffuser from which the air enters the room. So we need to capture this triangle because it is a sort of a singular geometry. I mean, it's the source of singularity in the geometry, and we need to capture this first before we move on to capture other aspects. So we will we'll split the block We go to here, split block, first option, edge, and we select, say, this edge, and we select the prescribed point option, and we select the corner of the triangle here. To capture this this triangle, we are splitting at the triangle corners, and we select apply. So this has been split. Now we want one more split to capture the second corner, and we say apply, and we prescribe point here, and then say again apply. So we have created a block near the triangle. We have made the splits. Now to capture the triangle, we will do merge vertices. We will merge this vertex with this so that the edge becomes parallel to the triangle. So this is we have already done this before in the module 1, basic geometries, quarter O grid. We see how to capture the triangle. We initialize a cubical block, and then we merge vertices. And say apply. Similarly, we merge the vertices on the other opposite plane and say apply. So you see the vertices have been merged and they have become parallel. And we can also use this option here to merge the vertices here. Say apply. Say apply. So the merge vertices has made the block smoother here, and the triangular shape has been captured. So if you switch off the curves and the surface, this is what the block looks like. So there is a triangle partition we have created which to capture the triangle, but we see that this division of block between this and this division here is kind of unnecessary. So we will merge the two blocks, these two blocks here. So we go to here, edit block, merge blocks, selected. We select this block and this block. When we have selected these two blocks, we have not selected a triangular block. Select these two blocks and press apply. So merge, the blocks have been merged, and now to complete the merging, we also need to merge the faces, the two faces which were split. So we'll go to merge faces in the same edit block option, the merge faces. Merge faces, we'll select the block faces and say block faces here, and we select these faces here and press middle click and say apply. So these faces have been merged, and then the opposite faces here, and then say apply. So we have captured the triangular shape here, and the block looks fine overall. Let me switch on the points. So if you see here, there is no surface here. I mean, there is no surface here. The surface ends here. So, but our block is extending till here. So we need to delete this portion of the block. So we will make one more split at this vertex and then delete out this portion here. We'll delete out this portion here. So we go to delete, we go to first split block, so that we split the edge here at this prescribed point here, and we say apply. So now our block has been split here in this direction to capture this triangle here, and then we can now do the deletion of the block here. We'll delete this this block here and say apply. So this block has been deleted because the surface here was like this. The surface here was like truncated, so we deleted the block to capture the truncated surface here. So this is what the block looks like after right now. So this is how the block looks like here. Now if you see, we can foresee the problem that once the mesh starts from this triangular edge, then it will have to merge with this rectangular mesh here, the triangular edge. So to ease out the mesh which comes from this triangle and merges here, to ease out this mesh, we'll create an O grid. We'll create an O grid which will not cover the triangular block here. The remaining block, we will create an O grid. So please pay attention as I create the O grid now. So I will go to split block. In blocking, select split second one, O grid block. I select the two blocks here, but I don't select the triangular block, and I press middle click. Now I also have to select faces. So I will select of course the top and bottom faces, the top and bottom faces, and the faces at the back and side. So I selected the top and bottom and the faces at the back and sideways at the plane of symmetry. Now I press middle click and say apply. So this is our O grid. So this edge will help in easing the transition from the triangle to the rectangle here. Let me switch on the curves. So we see when I switch on the curves here, I see that the O grid extends much further into the geometry because the edge extends till here, and we have lights which go till here, and also the tables which go till here. So so it looks important, it looks beneficial if we scale this radial edge a little lower. We make this lower so that this table is covered and this light is covered. So we'll try and scale the O grid. We'll make it make the radial edge smaller, so that it does not protrude into the region where the table is kept or where the lights are there. So we'll scale back this radial edge. So I go back to edit block. I say modify O grid, select edge, and I select I want the radial edge to be smaller, so our offset will be less than 1. I will start with say 0.9 and say apply. So now the block has come till here. I want it to come a little more outside, the radial edge to be smaller still. So I will still go say apply and then say apply. So I still want it to become smaller, so I will keep pushing it. Little more. So now we have made the radial O grid here, the radial edge smaller, so that the table is just outside the the edge ends before the table begins. We can make it a little more smaller here. So we have been able to avoid the table. So the edge now begins. Now the edge ends before the table begins. That was our motive of scaling the O grid. Now before we proceed further, let's do some associations. We will associate the triangles here and here. So we'll select the edge here and the curve here, say apply. So the edge here and the curve here, say apply. And the edge here, the curve here, say apply. Similarly, on the upper triangle, upper face, we'll have to select the two edges because the curve is not truncated here. So say apply. And we say so this is the association. We have not been able to associate this curve, but that shouldn't matter because it's already on the surface. It's not an internal curve. And then as we already know, perhaps, this is a triangular block. To improve the quality of mesh in this block, we should convert it into a Y block. So this block needs to be converted into a Y block. So I go to edit block, convert block type, select Y block, select the block, and this is the block selected, and press middle click and say apply. So this block has been converted to a Y block. This block has been converted to a Y block, and which will to improve the quality of the mesh. So this is what the blocking scheme looks like right now. So the triangle has been captured. Now the important thing is here is that all the surfaces in this which are enclosed by this block, these surfaces are internal surfaces in the geometry. These are the internal surfaces in the geometry here. So so they are like internal walls. I mean, the flow will not pass through them. They are like internal walls. So to capture the internal walls, we need that the internal edges should be associated with the internal walls. If the internal edges are not associated with the internal walls, internal CAD surfaces, then there is no the flow will pass through that CAD surface. So we need to create edges internally and then associate them with the internal walls. So to create the edges internally, first we will need to do some splits. We need to create some splits on these edges to capture to make them pass through the corner, to make them pass through the surfaces, to make them enclose the surfaces rather. So the splits should enclose the surfaces. So we will make splits which will be passing through these points. So let's do the splitting now. We have been able to capture the triangle, make the O grid, and now we'll start the splitting.